Welcome to Kendall's Tech Tutorials. This is Django, the big picture. Django is a powerful web framework, but when you first encounter its projects, applications, settings, models, migrations, URLs, views, forms, and templates, it can be difficult to understand how all the pieces fit together. In this tutorial, we're going to step back and look at the complete architecture. Then we'll start with an empty project directory and build a working contact management application from beginning to end. Our application will store contacts in a database and provide a complete create, read, update, and delete interface. Along the way, we'll distinguish a Django project from a Django application, follow a browser request through the entire request and response cycle, use models and migrations, work with Django's ORM, validate forms, add bootstrap styling, and record meaningful milestones with Git. By the end, you won't simply have watched a sequence of commands. You'll have a practical mental map of Django and understand how its major components work together. Let's begin with the big picture. Django is a web development framework written in Python. A framework is more than a package that performs one isolated task. It provides an organized foundation, along with conventions for building an entire kind of application. In Django's case, that application is usually a server-side website. When a browser asks for a page, Django receives that request on the server. Python code decides what should happen, retrieves or changes data when necessary, and returns a response, usually as an HTML page the browser can display. This request and response cycle is at the heart of every Django application. Django is also a collection of tools designed to work together. URL routing decides which code handles an address. Views coordinate the response, models and Django's object relational mapper work with database data. Templates combine that data with HTML to produce the finished page. Django is often described as batteries included, because common web features are already available. It provides forms and validation, authentication, and permissions, a built-in administration interface, and important security protections. Instead of assembling every fundamental piece from unrelated packages, we begin with one coherent framework and add specialized tools only when our application needs them. Django's popularity comes from practical advantages. First, it helps developers move from an idea to a useful working application quickly. Common tasks already have established patterns, so less time is spent building basic machinery. Its components are also designed to cooperate. Django encourages a consistent project structure, and its URLs, views, models, and templates follow recognizable conventions. That consistency makes projects easier to understand, maintain, and hand to another developer. The object relational mapper, usually called the ORM, lets Python code work with relational data without scattering database-specific queries throughout the application. Django supports several relational databases, including SQLite, PostgreSQL, MySQL or MariaDB, and Oracle. Many features applications commonly need are included: authentication, forms and validation, an administration interface, and important security protections. These tools share Django's conventions instead of feeling like unrelated parts bolted together afterward. Django also benefits from mature documentation, a large collection of reusable packages, and an established community. For many common requirements, we can find clear guidance, a proven approach, or an existing package worth evaluating. Django is useful across a wide range of projects. It can support a small internal application or form the foundation of a substantial public system. Django does not eliminate engineering, but it removes repetitive plumbing so developers can concentrate on the application itself. Before we go further, it helps to draw some boundaries around Django. Django is not a programming language. It is a web framework written in Python and used through Python code. It is also not a database, even though its models and ORM communicate with databases, and it is not a front-end framework like React or Vue. Its primary role is on the server. Django also does not replace the technologies that make a page work in the browser. We still create HTML for structure, CSS for presentation, and JavaScript when browser-side behavior is needed. Django can power a content management system, and projects such as Django CMS do exactly that. But Django itself does not automatically turn every project into a CMS. One more distinction is especially important. The convenient development server we will use is intended for local development and testing, not for serving a production website. Production requires an appropriate web server, security configuration, monitoring, and operational planning. Django provides excellent structure and tools, but it does not replace an understanding of HTML, HTTP, databases, security, or the broader fundamentals of web development. Django uses the words project and application in a specific way. A project is the complete website. It owns the overall configuration, including settings, top-level URL routing, and the collection of features that make up the site. An application, usually shortened to app, is one focused area of functionality inside that project. It can contain its own models, views, URLs, and templates. One Django project can contain several apps. A business website might have apps for contacts, accounts, reports, and inventory, all sharing the same project configuration. Apps also create a useful boundary. When an app is designed to be self-contained, it can sometimes be installed in another Django project. Not every app is automatically reusable, but Django's structure makes reuse possible. For our tutorial, the project is the complete demonstration website. Inside it, we'll create an application named Contacts. That app will contain a model class named Contact and the features used to list, view, add, edit, and delete contact records. Notice the naming in our example. The application package is lowercase and plural, contacts, while the model class is singular and capitalized, contact. That distinction will make the code easier to read as the project grows. Every Django page begins with a request from a browser. The browser asks for a URL, and Django's URL configuration determines which view should handle it. The view coordinates the work. If the request needs stored information, the view uses a model to read or change data in the database. When the necessary work is complete, the view supplies information to a template. The template combines that information with HTML, and Django returns the finished page to the browser. Not every request needs database access, which is why the model step is conditional. These three responsibilities give Django its model view template, or MVT, terminology. The model represents and works with data. The view makes decisions and coordinates the response. The template controls how the result is presented as HTML. URL configuration is not one of the three letters, but it is the dispatcher that selects the view and starts the MVT portion of the process. Forms travel through essentially the same path. A browser submits form data to a URL. The URL configuration selects a view, and the view validates the submitted values. If the data is valid, a model can save it. If it is invalid, Django returns the form with error messages instead of saving bad data. In either case, a template renders the next response, and Django sends another page to the browser. The extra step is validation. Submitted data is checked before it is trusted or stored. A Django model is a Python description of information that we want to store. Each model generally corresponds to a table in the database, and its fields describe the information stored in that table. In our demonstration, the contact model will contain two fields, name and phone number. Each saved contact becomes a record in the corresponding database table. Django's Object Relational Mapper, usually shortened to ORM, acts as a bridge between our Python code and those database records. We work with contact objects in Python, and the ORM translates that work into database operations. Both of our fields contain text, but they hold short, length-limited values, so we will use char field rather than text field. A phone number should also be stored as text, because it may contain spaces, punctuation, country codes, or leading zeros. We display phone numbers, we do not perform arithmetic with them. When we create or change a model, the structure of the database may also need to change. Django records these structural changes as migrations. The make migrations command prepares a migration file describing what needs to change. The migrate command then applies any unapplied migrations to the database. This gives Django a recorded and repeatable history of the database structure instead of changing tables silently behind the scenes. Here is a simplified map of a typical Django project. At the top level, we have the project management utility, our demonstration database, the project's configuration package, and one or more application folders. The exact names can vary, but this overall organization will look familiar in most Django projects. The manage.py file gives us access to project management commands. We will use it to start the development server, create migrations, apply migrations, and perform several other tasks. The settings.py file contains the project's configuration, while the project-level urls.py provides the top-level URL routing and directs requests toward the appropriate application. Inside our contacts application, models.py describes stored data, and views.py contains the request handling logic. The application can have its own urls.py containing routes specific to that application. Its templates directory contains the templates Django uses to generate HTML pages. The migrations directory records the history of database structure changes. For this demonstration, Django will use SQLite as our database. You will also see sgi.py and wsgi.py in the project package. These provide entry points used when connecting Django to deployment servers, but deployment deserves its own tutorial. For now, we simply need to recognize what those files are. Before we begin the demonstration, let's look at the general workflow we will be following. A Django project usually begins with an ordinary project directory. Inside it, we create and activate a Python virtual environment, install Django, and then use Django's tools to create the initial project structure. Next, we configure the project and create an application to provide a particular area of functionality. We define the application's models, prepare migrations describing the required database structure, and apply those migrations to the database. We then create the views and forms that handle requests and user input. URLs are connected to the appropriate views, and templates provide the HTML shown in the browser. Throughout development, we repeatedly run the application, test our work, correct problems, and continue building. Git should be initialized early rather than treated as a final step. As meaningful parts of the application begin working, we commit those milestones so we have a clear and recoverable development history. Eventually, a finished application must be tested more thoroughly, configured for its production environment, and deployed using production-grade services. That is an important part of the larger Django workflow, but it comes after the application itself is working, and will be covered separately. Now we can begin building our Django project. I'll start inside my work directory by creating a new directory named Django Contacts Demo, and then entering it. Next, we'll create a virtual environment named .vend and activate it. This gives the project an isolated Python environment, so its packages remain separate from other Python projects on this computer. We covered virtual environments in detail in an earlier tutorial, so we'll move quickly here. We'll initialize Git before creating any application code. Starting version control early allows us to record meaningful milestones as the project develops. Next, we'll create a .gitignore file. We'll exclude the virtual environment, Python cache files, our demonstration database, and the .env file that may eventually contain private configuration. Notice that we are not excluding Django migrations. When migrations are created, they become part of the project's source history and normally belong in Git. Next, we'll install Django using pip. Our pip tutorial explains package management in greater detail, and our UV tutorial demonstrates a faster modern alternative. For this Django overview, ordinary venv and pip keep the commands familiar and let us concentrate on Django itself. Finally, pip freeze records the installed package versions and requirements.txt. This makes the environment reproducible on another computer. Git's short status display shows the two new project files while the ignored virtual environment remains absent from the list. Django is installed, so we can now create the project itself. The start project command builds a new Django project package named config. The period at the end tells Django to place managed by Py and the project files inside our current directory instead of creating another outer directory. Let's briefly examine what Django generated. Managed by Py is the project management utility we will use throughout the demonstration. Inside the config package, settings by Py contains the project configuration, URLs by Py provides top-level URL routing, and asgi by Py and wsgi Py provide entry points used during deployment. Before starting the website, we'll run Django's migrate command. Django includes several built-in applications, including authentication, sessions, and the administration interface. These initial migrations create the database tables those components require. Now we'll start Django's development server. This server is convenient while building and testing an application, but it is not intended to serve a production website. I'll switch to Firefox and open the local address shown in the terminal, 127 by 0 by 1, port 8000. Django's successful installation page confirms several things at once. Django is installed, the project configuration loads correctly, the development server is running, and Firefox can communicate with Django. We'll return to the terminal and stop the server with Ctrl+C. Git shows the newly created project files. We'll stage them and create our first commit with the message: create base Django project. The final Git log confirms that our clean starting point has been recorded. Now that the base Django project is working, we can replace Django's installation page with our own home page. I'll begin by confirming that we are still inside the project directory and creating a project-level templates directory. Inside that directory, we'll create base.html. This shared template provides the common HTML structure that other pages can inherit. It also loads the Bootstrap style sheet from a Content Delivery Network, or CDN. We are not installing a Python package or adding a front-end build system. When the browser loads one of our pages, it retrieves Bootstrap's prepared style sheet directly from the CDN. This gives us useful styling without introducing node, npm, or additional build commands. Our home.html template extends base.html and supplies the page-specific title and content. It displays "Welcome to our Django app" and provides a button leading to the future contact list. That address will begin working after we create the contacts application. Next, we'll create a small home view. Its job is simply to render the home page template. Django must also be told where to find our project-level templates, so we'll add the templates directory to the dirs setting. Finally, we'll connect the site's root URL to our new home view. Django's check command verifies the project configuration before we start the development server. I'll switch to Firefox and load the prepared local address. Our styled homepage confirms that the view URL route, template discovery, template inheritance, and bootstrap style sheet are all working together. We'll then return to the terminal and stop the server with Ctrl+C. Our project now has a working home page, so we are ready to create its first application. The start app command creates a Django application named contacts and gives it the standard application structure. Creating the files is not enough by itself. We must also register the application in installed apps, so Django knows that it belongs to this project. We'll use the generated contacts config class to identify it explicitly. Next, we'll define our contact model. A model is a Python description of information that Django will store in the database. The name field will use a char field with a maximum length of 100 characters. The phone number field will also use char field with a maximum length of 30 characters. Although phone numbers contain digits, they are identifiers rather than quantities. Storing them as text preserves spaces, punctuation, country codes, and leading zeros. We'll also define the model's string representation. Returning the contact's name gives Django a useful human-readable label whenever it displays a contact object. Django's check command verifies the new configuration and model definition. The make migrations command then converts the Python model change into a migration file. At this point, Django has described the required database change, but it has not applied it yet. The migrate command applies that migration and creates the corresponding database table. Finally, show migrations displays a checked entry beside the initial contacts migration. This is the same sequence we introduced earlier: Python model migration database table. Now we'll use Django's shell to create some sample data. Unlike an ordinary Python shell, this shell loads our Django project configuration and gives us access to its models and database. We'll import the contact model and create a list containing 10 fictional contacts. Each phone number uses the reserved 555 range, so none of these examples should belong to a real person. The ORM's bulk create method inserts all 10 contact objects efficiently in one database operation. Next, we'll query the contacts and order them by name. Django retrieves the records from the database, and our loop displays each contact's name and phone number. Finally, the count method asks the database how many contact records it contains. The result is 10, confirming that every sample contact was stored successfully. We'll then exit Django's shell and continue building the application. CRUD is an acronym for the 4 basic ways an application works with stored data: create, read, update, and delete. In our contact manager, creating means adding a contact. Reading includes both listing all contacts and inspecting one contact. Updating means editing an existing contact, and deleting means removing it from the database. We'll implement these operations with URL routes, Django's generic class-based views, and 4 templates. The create and update views will share one form template because both operations collect the same fields. Django's generic views provide most of the standard behavior, allowing us to build the complete interface with relatively little Python code. Now back to our demonstration. We are going to build the complete CRUD interface by connecting 3 layers of the application: URL routes, Python views, and HTML templates. We will work through them one file at a time. The first file we will edit is config/urls.py. This is the project-level URL configuration. Its job is to recognize the broad sections of the website and delegate each request to the appropriate part of the project. I'll open config/urls.py at line 18. The existing import brings in Django's path function. Path allows us to associate a URL pattern with a view. We are going to add the include function to that same import. Include allows one URL configuration to hand part of the routing work to another URL configuration. That means the project level file does not need to know every individual contact address. It only needs to know that addresses beginning with contacts / belong to the contacts application. We'll save that first change. Now we'll reopen config/urls.py at the section containing URL patterns. The root route that we created earlier still sends the empty address to our home view. We are going to add a second project level route for contacts /. This path begins with the text contacts /. Its include call tells Django to continue matching the remainder of the address inside contacts.urls. For example, when the browser requests contacts/add/, this project level route removes the contacts portion and hands add/ to the contacts application. We are inserting the contacts route before restoring the existing administration route on the following line. The administration interface remains available at admin/, even though we will not configure it further in this overview. We'll save config/urls.pya. The completed project level URL configuration now recognizes three broad destinations: the home page, the contacts application, and Django's administration interface. The contacts application will manage its own detailed routes. The next file will be new. We are creating contacts/urls.py. This is the application level URL configuration. It will define every address belonging specifically to our contacts application. At the top of the file, we import Django's path function. We need path here for the same reason we needed it in the project configuration. Each call connects an address pattern to the view that handles it. Next, we import 5 view classes from the application's views file: contact create view, contact delete view, contact delete view, contact list view, and contact update view. Those view classes do not exist yet. We will define them immediately after this file. Python can import them once both files are complete. The app name line creates a URL namespace named contacts. A namespace prevents route names from colliding with similarly named routes in other applications. Because of this namespace, the complete name of our list route will be contacts:list. The create route will be contacts:add, and the remaining routes will follow the same pattern. Now we begin the URL patterns list. The first path contains an empty string. Remember that the project level configuration has already matched and removed contacts /, therefore, an empty application route represents the address /contacts /that route. Calls contact list view.as view. Class-based views must use as view when they are connected to a URL. As view converts the class into a callable Django can invoke for an incoming request. We give this route the name list. The second route matches add/. It connects that address to contact create view and gives it the name add. Its complete address will be /contacts/add/. The remaining 3 routes contain int::pk inside angle brackets. pk stands for primary key. Every contact record receives a unique primary key from the database. The int converter requires that portion of the URL to contain an integer and provides the resulting value to the selected view. The plain primary key route connects to contact detail view. An address such as contacts/3/ asks Django to display the contact record whose primary key is 3. The next route adds edit/ after the primary key. It connects to contact update view. That view will retrieve the specified contact and display a form containing its current values. The final route adds delete/ after the primary key and connects to contact delete view. It will display a confirmation page before removing the specified record. Each path also receives a name: detail, edit, or delete. Templates can combine those route names with a contact's primary key to generate the correct addresses. This is much safer than writing addresses manually throughout our HTML. If we later change the structure of a URL, we can update the route here instead of searching through every template. We'll save the new contacts/urls.py file. Our URL configurations now describe where requests should go, but the imported view classes still need to be created. The next file we will edit is contacts/views.py. Recall Django created this file when we ran start app. It currently contains a placeholder import and comment. We are going to replace that placeholder with the 5 generic class-based views referenced by contacts/urls.py. We'll begin at the first line. The first import brings in reverse lazy from Django.urls. Reverse lazy converts a named URL, such as contacts:list, into its eventual address. The lazy version waits until Django's URL configuration has been loaded before performing that conversion. This is useful in a class attribute because Python reads the views module while the project is starting. Using reverse lazy prevents us from trying to resolve the URL too early. We'll save that first import. Now we'll reopen contacts/views.py at line 2. This line imports 5 generic view classes supplied by Django: create view, delete view, detail view, list view, and update view. These classes implement common database backpage behavior. Instead of writing the same request handling logic ourselves, we can configure these generic views with a model, a few fields, and a destination. We will explain class-based views in much greater detail in a later tutorial. For this overview, concentrate on the responsibility represented by each class. We'll save the generic view import. Now we'll reopen contacts/views.py at line 3. The third import brings in the contact model from the current application's models file. The leading dot means that models.py is located in the same Python package as this view's file. Every view in this file will work with contact records, so they all need access to that model. The first class we define is contact list view. The name is our choice, but inheriting from list view gives the class its behavior. A list view retrieves a collection of model objects and supplies them to a template. The model attribute tells the view which kind of object to retrieve. We set it to contact. The ordering attribute tells Django to sort the results by the name field. Because the field name appears inside a list, this class could later include additional sorting fields if necessary. When /contacts/ is requested, this view will retrieve all contact records ordered by name. By convention, it will look for a template named contacts/contactlist.html. It will provide the retrieved collection to that template using the default context variable named objectList. The second class is contact detail view. It inherits from detail view and also uses the contact model. A detail view retrieves one model object rather than a collection. It receives the primary key value captured by the URL, asks the database for the corresponding contact, and supplies that object to its template. By convention, it will use contacts/contactdetail.html. The selected contact will be available in that template through the variable named object. The detail page will remain read-only. It will display the record and provide links to separate editing and deletion pages. This keeps reading and changing data as distinct operations. The third class is contact create view. It inherits from Django's create view and uses the contact model. The fields list contains name and phone number. Django reads those model fields and automatically constructs a model-backed form containing the appropriate inputs. When the browser requests the add page with an ordinary GET request, create view displays an empty form. When the user submits the form with a post request, create view validates the submitted values. If the values are valid, it creates and saves a new contact object. If validation fails, the same form is rendered again with error information. Invalid values are not saved. The success URL uses reverse lazy with contacts:list. After a new contact is saved successfully, Django redirects the browser to the contact list page. The fourth class is contact update view. It inherits from update view and uses the same contact model in the same two fields. Unlike create view, update view receives a primary key from the URL. It retrieves the existing contact and fills the form with that record's current name and phone number. When the form is submitted successfully, Django updates that existing object instead of creating another one. It then redirects to the same contact list route. Create view and update view can share one template because both provide a variable named form and collect exactly the same fields. We do not need to create a separate forms.py file for this simple application. The generic views create the required model forms for us. The fifth and final class is contact delete view. It inherits from delete view and uses the contact model. When the delete address is opened, the view retrieves the contact identified by the primary key and displays a confirmation template. The record is not removed by simply visiting that address. Deletion occurs only after the confirmation form submits a post request. After deletion, reverse lazy sends the browser back to contacts:list. These 5 classes now provide the Python behavior behind all 5 application routes: list, detail, create, update, and delete. We'll save contacts/views.py. The routes and views are connected. Now the views need templates that determine what the browser will display. We'll create the directory contacts/templates/contacts. The first contacts is the application directory. Inside it, templates marks the location where Django should search for application templates. The second contacts directory creates a template namespace. That extra directory level may appear repetitive, but it prevents file name collisions. Another application could also contain a file named contactlist.html or form.html. Placing our files inside a contacts subdirectory gives each template an application-specific path. This structure also matches the default file names expected by Django's generic class-based views. The first template we will create is contacts/templates/contacts/contactlist.html. This template is used by contact list view. Its purpose is to display the complete collection of contact objects. The first line extends base.html. Extending the base template means this page inherits the shared document structure, navigation bar, Bootstrap style sheet, and main content container that we created earlier. The title block supplies the browser tab title for this page. It replaces the default title block from base.html with contacts, followed by Django contacts. The content block supplies the visible page content. Inside that block, the first div uses Bootstrap Flexbox classes. It places the contacts heading on one side and the Add Contact button on the other. The margin bottom class provides space below the heading row. The Add Contact button does not contain a hard-coded /contacts/add address. Instead, its URL tag asks Django to reverse the named route contacts:/add. Django looks up that route in contacts/urls.py and generates the correct address. This is our first example of the route names doing useful work inside a template. Below the heading, we create a Bootstrap list group. The template for loop iterates through object list. That is the collection supplied automatically by contact list view. For every contact in the collection, the template creates a clickable list group item. The link uses contacts:/detail and supplies contact.pk. Django inserts that contact record's primary key into the detail root pattern. Inside the link, another Bootstrap Flex container places the contact's name on the left and telephone number on the right. Double curly braces tell Django's template engine to display a value. Contact.name displays the name field, while contact.phone number displays the phone number field. These values are escaped by default before being inserted into the HTML. That is an important part of Django's protection against unsafe content. The empty portion of the loop handles the case where the database contains no contacts. Instead of displaying an empty panel, the template shows a message explaining that no contacts have been added. Finally, we close the list group div and the content block. We'll save contactlist.html. The next file we will create is contacts/templates/contactdetail.html. Contact detail view will use this template to display one contact object. As before, the template begins by extending base.html. Its title block identifies the page as contact details. The content block creates a Bootstrap card. The shadow class helps the card stand out against the page background. Inside the card body, the heading displays object.name. The variable is called object because that is the default context name supplied by detail view. In this template, object represents the single contact selected by the primary key in the URL. The following paragraph displays object.phone number. The word phone is marked with the strong element to give it visual emphasis. Notice that this template contains no input fields and no form. The detail page only reads and displays stored information. Below the contact information, we create 3 buttons. The back button reverses contacts:/list and returns to the complete collection. The edit button reverses contacts:/edit and supplies object.pk that produces the edit address for this specific contact. The delete button does the same with contacts:/delete. The primary key is what allows one shared route and one shared view class to work with any contact record. Separating these links also makes the application's behavior explicit. Viewing the detail page does not silently place the record into an editable state. The user must deliberately choose edit or delete. We'll save contactdetail.html. The next file will be contacts/templates/contacts/contactform.html. This one template will serve both contact create view and contact update view. Django's naming convention is important here. Both create view and update view look for a template whose name ends with _form because both views use the contact model. They both find contactform.html. The template extends base.html. Inside the title block, we test whether a variable named object exists. Update view supplies an existing object because it is editing a saved contact. Create view does not yet have a saved object. If object exists, the page title says edit contact, otherwise it says add contact. We repeat that same conditional inside the visible H1 heading. This allows one template to identify its current purpose without duplicating the entire file. Next, we begin an HTML form. The method is post because submitting this form changes data. A create submission inserts a new record, while an update submission modifies an existing record. The bootstrap card and shadow classes provide the form's visual container. Immediately inside the form, we include Django's CSRF token. CSRF stands for Cross-Site Request Forgery. Django uses this hidden token to verify that a data-changing form originated from a page it generated for the current user. Without the token, Django will reject the submitted post request. Every internal Django form that changes data should include this protection. The form.asp expression renders the fields supplied by createView or updateView. Django generates labels and input elements for name and phone number. Wrapping them as paragraphs gives the fields a simple readable layout. The same form object also carries validation errors. If submitted information is invalid, Django can render this template again and show the errors alongside the relevant fields. The Save Contact button submits the form. The Cancel button uses the named contacts list route and returns to the list without submitting changes, because the view supplies the behavior and the template supplies the presentation. This single file works for two different CRUD operations, create and update. We'll save contact form.html. The fourth and final application template will be contacts/templates/contacts/contact confirm delete.html. Contact. Delete view uses this template before it removes a record. The template extends base.html and sets the page title to delete contact. The visible content uses a bootstrap card with a red danger border. This helps distinguish deletion from ordinary viewing and editing. The heading clearly says delete contact. The confirmation message asks whether the user is sure and displays object.name in bold. As with detail view, the object variable represents the contact selected through the primary key. Next, we create a form whose method is post. The form contains another CSRF token, because deletion changes stored data. This distinction is important. Opening the confirmation page uses get and does not delete anything. Selecting the confirmation button submits post, and only then does delete view remove the record. The red delete contact button submits that request. The cancel button reverses contacts:detail with object.pk. It returns to the same contacts read-only detail page without deleting anything. This confirmation step helps prevent accidental destructive actions and makes the user's intention explicit. We'll save contact confirm delete.html. Our four application templates are now complete. Contact list view uses contactlist.html. Contact detail view uses contactdetail.html. Contact create view and contact update view share contact form.html. Contact delete view uses contact confirm delete.html. Django found all four through predictable generic view naming conventions, so we did not need to set template name explicitly in the Python classes. We have one final template edit to make. The file is the project-level templates/home.html. When we originally created the home page, the View Contact List button contained the literal address/contacts/. That temporary link allowed us to build the home page before the contacts application existed. I'll open home.html directly at line 10, where that link appears. We are keeping the button's bootstrap classes and visible text. We are only replacing the hard-coded href value. The new href contains Django's URL tag with contacts:list. Django now looks up the named list route and generates the address. The home page no longer needs to know that the route currently happens to be /contacts/. If we later change that address in the URL configuration, this link will continue to work without modification. We'll save templates/home.html. At this point, the project-level URL configuration delegates to the application. The application URL configuration selects the appropriate view. The views retrieve or change contact objects, and the templates generate the HTML shown in the browser. Before running the server, we'll ask Django to inspect that entire configuration. The command is python manage.pycheck. The system check loads the project, imports the URL, configurations, and views, examines the models, and looks for common configuration problems. The message stating that Django identified no issues confirms that our Python imports and project configuration can load successfully. Now we'll run python manage.py run server. Django starts its development server at the local address 127.0.0.1, port 8000. As before, this server is intended only for development and testing. It should not be used as a production web server. The server is now waiting for browser requests, so I'll switch to Firefox. I'll open the home page. Our home page still uses the shared base template and bootstrap styling. I'll select View Contact List. The named URL sends the browser to /contacts/. Contact list view queries. The contact model orders the results by name and supplies them to contactlist.html. The list displays the 10 sample contacts that we created through Django's shell. This is the collection form of the read operation. I'll select Avery Brooks. The URL now contains Avery's primary key. Contact detail view uses that value to retrieve the correct contact and supplies it to contactdetail.html. The detail page displays the name and telephone number, but contains no editable fields. This is the individual record form of read. Now I'll select Edit. Contact Update view retrieves Avery's record and supplies a model-backed form containing the current values. I'll change the telephone number. The form contains the existing name and our new telephone number. I'll select Save Contact. Django validates the values, updates the existing contact record, and redirects to contacts:*list. Avery Brooks now displays the new number. That confirms the update operation succeeded. Next, I'll select Add Contact. Contact Create view supplies the same contact form.html, but this time the form is empty because there is no existing object. For the name, I'll enter Sam Parker. For the telephone number, I'll enter a number. I'll select Save Contact. Django validates the form, creates a new contact record, and returns to the list. Sam Parker now appears in alphabetical order. That confirms the create operation succeeded. I'll select Sam Parker to open the new records detail page. Now I'll select Delete. Contact Delete view retrieves Sam's record, but does not remove it immediately. It renders contact confirm_delete.html and asks us to confirm the operation. The page identifies the contact by name and provides both delete contact and cancel buttons. I'll select Delete Contact. The confirmation form submits a protected post request. Delete view removes Sam Parker and redirects to the list. Sam no longer appears, while our original 10 contacts remain. That confirms the delete operation succeeded. We have now exercised all 4 CRUD operations through the browser. We created Sam Parker. We read the complete list and individual detail pages. We updated Avery Brooks. And we deleted Sam Parker using a confirmation page. I'll return to the terminal. The development server is still running. We type Ctrl+C to stop it. Now that the complete browser test has passed, we'll run python manage.py check one more time. This final check confirms that Django can still load the completed configuration after all our URL view and template work. Next, we'll run git status with the short option. Git lists the files created and changed since our first commit. These changes include the home page, the contacts application, the model, and migration, both URL configurations, the 5 views, and the 4 CRUD templates. The sample contact records do not appear in git status because they are stored in SQLite, and our git ignore file deliberately excludes that development database. Now we'll run git add. This stages the project files in the current directory. Staging tells Git exactly which changes should become part of the next commit. Next, we'll create the commit with the message, build contact, CRUD interface. This is a meaningful milestone. The first commit recorded the empty base Django project. This second commit records a working database-backed application with models, migrations, routes, views, forms, templates, bootstrap styling, and a complete CRUD interface. Finally, we'll run git log one line 2. The log displays our 2 project milestones in compact form, create base Django project, followed by build contact CRUD interface. Our demonstration application is now complete. Before the demonstration, we followed this request cycle using general Django terminology. Now we can reconstruct the same cycle using the components we actually built. When Firefox requests /contacts/ Django's URL routing selects contact list view. The view asks the contact model for the stored contacts, ordered by name. Django's ORM translates that request into a database query and reads the records from our SQLite database. The results return through the model as contact objects. Contact list view receives those objects and supplies them to contactlist.html using the name object list. The template loops through that collection, combines the contact information with our HTML and Bootstrap styling, and produces the completed response. Django returns that HTML to Firefox, which renders the contact list page we saw during the demonstration. The abstract sequence has not changed: request, view, model, database, template, and response. We can now connect every stage to a real URL, Python class, model, database file, template, and browser page from our own project. CRUD gives us a convenient shorthand for the 4 fundamental operations we implemented. Create adds a new record. In our application, that happened when we completed the add contact form and saved a new contact. Read retrieves stored information. We used read both to display the complete contact list and to inspect one contact on its detail page. Update changes an existing record. Our edit button opened a form containing the contact's current values, and Django validated and saved our changes. Delete removes a record. We used a separate confirmation page to make that destructive action deliberate. Most database-backed business applications are combinations and extensions of these same 4 operations. An inventory system, ticket system, customer portal, or online store may add permissions, reporting, and business rules, but much of its daily work still comes down to creating, reading, updating, and deleting stored information. Let's bring the complete Django workflow together one final time. We began by creating a project and then added the contacts application. Inside that application, we defined the contact model. A migration translated that Python model into a repeatable database structure change. URL configurations connected browser addresses to views. The views coordinated each request, worked with the model when data was needed, and supplied information to templates. Those templates generated the HTML that Django returned to the browser. Several supporting concepts worked throughout that sequence. Forms validated, submitted values before Django trusted or saved them. The ORM communicated with the database while allowing our Python code to work with contact objects. Bootstrap styled the rendered HTML without requiring us to build a separate front-end toolchain. Git recorded meaningful development milestones and gave the project a recoverable history. Most importantly, Django supplied much of the repetitive infrastructure. Routing forms, validation, database access, templates, and generic views allowed us to concentrate on the behavior of our application instead of rebuilding common web development machinery from scratch. A Django application is not one mysterious piece of software. It is a collection of models, URLs, views, forms, and templates working together through a predictable request and response cycle along the way. We distinguished the overall Django project from the individual applications inside it. We followed requests from the browser to a view and back again, connected Python models to database tables through migrations, and used Django's ORM to work with stored records. We also used Django's convenient development server throughout the demonstration. Remember that this server is intended only for development and testing. A production website requires proper production configuration and a production-grade server. From here, our Django Essentials series will examine each part of this architecture in much greater detail. If you'd like to know more about the virtual environment or pip commands that we used here, check out our tutorials on venv and pip. If you found this information useful, be sure to like and subscribe. This helps other folks find our tutorials as well. Thanks for watching.